Hello, everyone. I wanted to take a moment and discuss compound inequalities with you guys. Now, when we talk about compound inequalities, there was some kind of blinking there. I hope the video is doing okay. Yeah, I think it's still being recorded. So when we talk about compound inequalities, guys, I want you to think about compound qualities back in your English classes. Compound sentences. Compound sentences were two independent thoughts separated with a conjunction. And the conjunctions, we use the acronym FINBOYS to remember them. For, and, nor, but, or, yet, so. Those are the FINBOYS. Likewise, we have compound inequalities in math classes. So in math class, we use two conjunctions to separate two inequalities, guys. We use the word and, we use the word or. So basically, there's two types of compound inequalities you will encounter in a math class. The first one is the intersection. And when we talk about the intersection, we use the word and to reference it. The symbol we use to reference the intersection looks like an upside down U. Some people even see a letter N. Personally, I like to reference it as the letter N because you know that would be closer to the word end. That would make more sense. So the intersection, guys, is the first type of compound inequality we discussed in our math classes, okay? The intersection. Next, we have the union. This is the second one. The union, we use the word or to reference it. And the symbol we use for that is actually the U. See, I like that one because we're actually using that U symbol. And so we're going to go ahead and talk about these two compound inequalities. So let's start off with the intersection, guys. When we talk about the intersection of two sets, we use the word and to reference the intersection. And then the symbol, of course, is that upside down U or the letter N. So this references basically all the elements which two sets have in common. All the elements which two sets have in common. Now, the best way to express this, guys, to show you this, is through a Venn diagram. I know you guys are wondering, what is Venn diagram? No, you're not, because I know you know what a Venn diagram is, okay? So here's the Venn diagram. I've got set A and set B. And then in set A, I have the elements 1, 2, 3. Now, set B will have the elements 2, 3, 4, and 5. So if you were asked the question, what elements, okay, are in set A and in set B, guys, okay, that's the question. What elements are in set A and in set B? And so the question is simply asking, what do these two sets have in common? What elements do you notice in both sets? And the elements that you notice in both sets that appear in both A and B would be the 2 and the 3. And guys, that's it. 2 and 3 would be the intersection of the two sets. So what does this have to do with inequalities? Well, let's go ahead and look. When it comes to the inequalities, guys, okay, I'm going to double check and see if this is being recorded right now because I want to make sure it is being recorded. There we go. All right, yeah, it is being recorded. Okay, awesome. So back to this, guys. When we're talking about what this has to do with inequalities, if we had to graph x is greater or equal to -2 and x is less than 3, they're looking for the solution set, okay, between x is greater or equal to -2 and x is less than 3. So again, this is asking us simply, what numbers are both greater or equal to -2 and less than 3? So whatever the set of solutions are, they have to satisfy both inequalities. So guys, what I'm doing now is plotting these two values on the number line, which divides the number line into 3 regions. And so your job is to figure out which region or regions has the numbers that would make both inequalities true at the same time, okay? So I am going to go ahead and test with my favorite number, and my favorite number to test with is 0. So I plug the 0 in to the first inequality and test it out. Is 0 greater or equal to -2? Yes. Then I go to the second one, and I'm going to go ahead and plug it in. Is 0 less than 3? Yes. Okay. So because the number I tested with makes both inequalities true, guys, then this means that the region number 2 is true. This is where you're going to go to find all the values that would make both inequalities true. I hope that's making sense to you guys. Remember, I'm just recording the sound over this now because the first one did not have audio to it. All right, guys. Now, if you're not sure about the other 2 regions, you can go ahead and plug in some other values. And so in region 3, if I were to choose 5 to plug in there, let's test it out. Is 5 greater or equal to -2? Yes. Is it less than 3? No. So since 5 didn't satisfy both inequalities, it can't be, or that region cannot be part of the solution set. So we're going to do the same thing with region 1. We plug in -5 in there. Okay, is -5 greater than or equal to -2? Absolutely false. So you don't even have to go to the other one. You know that's already false. So this means that your solution set is going to be between the -2 and the +3. So now, guys, we're going to graph this. When graphing this, you can use a bracket on the -2 because of the inequality symbol, or that shaded dot. And then on the +3, you want to use a parentheses or the open dot to show that the boundary value is excluded. Then you want to shade in between to show all those numbers, okay? All those numbers that will make both inequalities true. Now, of course, they're going to want us to write this in interval notation too, so we are going to be writing it in interval notation. Remember, guys, when you are graphing, if you have greater than or equal to, less than or equal to, use a bracket. If you have greater than, less than, use parentheses, sugar plums. Now, the interval notation, remember, moves from left to right in numerical order, guys. Starting on the left, you have a bracket with the -2, comma, you continue to the right up to +3, close it off with a parentheses. So there you go. Not bad. Now, we're going to move on to the second one, guys. And that is the union. For the union, guys, we use the word or to reference the union. The symbol we use for that is U. And so, what is the union? The union represents all the elements from both sets or from 2 sets combined. All the elements from 2 sets or from both sets combined. So in other words, guys, you're taking elements from one set and elements from a second set and combining them together to create a larger set. Now, best way to express this is through a Venn diagram. So set A has the elements 1, 2, 3. B has the elements 2, 3, 4, 5. If they ask you the question, what is the union of set A with set B? What's the union of set A with set B? So when they ask you this, guys, think about it. They want the 2 sets combined. So they want elements that could just be in A, or elements that are just in B, or elements that are in both A and B. So as long as those elements satisfy one out of the 3 requirements, then yes, it's a part of the union. So in the case of the union of A with B, it would include the elements 1, 2, 3, 4, and 5. Okay, so all of them put together. And that's it. All right. Now, think of a union, guys, as a marriage, like the Brady Bunch or something like that. The lovely lady came with her 3 kids, and the man came with his 3 kids, and they got together and married each other, and they became what? The Brady Bunch. I would sing it for you guys. I just don't feel like singing right now. And so, yeah, maybe I'll sing it in class or something like that. My voice is a little raw, so I can't sing it right now, guys. Okay. So that's what it is, guys, when we talk about the union. So what does this have to do with the inequalities? So let's go ahead and look at the inequalities now. I'm going to give you an example so we can go ahead and chat about it a little bit more. So here comes the example, guys. Let's see here. We have x is less than or equal to -2. Or, see that operative word in there? X is greater than 3. So on this one right here, guys, you want to make sure, first of all, you go to the number line, put those numbers on the number line, which is going to divide the number line into 3 regions. Just like with the previous problem, the intersection, you want to go ahead and test each region, and your job is to figure out which region or regions will have the solutions that will make the inequalities true. And in this instance here, the numbers that you select, guys, it only has to make one of the inequalities true. As long as it does, then that's your solution. So as you can tell, we have a set of values going from +3 up to +infinity. And then on the other interval, you want every x, every value less than or equal to -2. Now, notice, guys, for this one, the union, the graph is disconnected. This doesn't always happen, but for the majority of the time, when we talk about the union graph, it is going to be a disconnected graph. And so when we talk about the intersection, typically the intersection graph is one interval, while the union graph represents 2 intervals. So you got to write this in interval notation, guys. And so because you have 2 separate distinct intervals, you got to make sure you use that union symbol to show that these 2 belong to one compound inequality. So on the left, we have the interval from -infinity to -2, and that -2 is included. And then on the right, we have the interval from 3, which is not included, up to +infinity. And you got to show that these 2 intervals belong together. So use the U symbol in the middle. And yes, you have to use that U symbol in the middle. I don't think you guys are going to get any of them like that on your assignment, but just keep an eye out for them, guys. But I do know for sure you're going to have to write interval notation, okay? So make sure you know what you're doing. You got to practice with these to become better at them. And when we're in class going over the problems, make sure you guys ask plenty of questions. So now I am going to do some specific examples for you. And these examples, you will see them on your assignment. So here comes number 1, guys. Now the goal of this problem is to isolate the x in the middle. You no longer have just 2 sides to the problem, you have 3 regions. You have the left region, middle region, and the right region. So your job is to isolate that variable in the middle, okay? So whatever you do to one region, you must do it to the others. And so on this one right here, you want to start off by adding the 18 to the middle, to the right, and to the left. So this simplifies to -2 plus 18 is 16. Less than or equal to 2x. Less than or equal to 26. Divide everything by 2. And there you go, guys. So now you got to write this in interval notation. Now, until you feel comfortable with writing things in interval notation, You might want to keep graphing them, guys, on the number line so you can go ahead and use them as a guide to help you write your end of notation. And remember, when you write the end of notation, you're going from left to right, guys. Starting on the left with a bracket at 8, and then moving to the right, and ending up at positive 13 with a bracket, okay? So be careful with this. I know it's too low at the bottom, so let's go ahead and move it over to the side. There we go, that's better. All right. Now let's move on to a second one. I'm only doing 3 examples, guys. Negative 6 is less than 6 minus 2x less than or equal to 10. So we started by subtracting 6 from the middle, 6 from the left, 6 from the right. So this leaves us with negative 12 less than negative 2x less than or equal to positive 4. Now you want to divide everything by negative 2. Guys, be careful because you're dividing by a negative. You're going to have to reverse switch, flip the inequality symbols, okay? So the 2's cancel out in the middle, leaving you with x. 4 divided by negative 2 is negative 2. Negative 12 divided by negative 2 is 6. So there's your answer. What you will notice is that this is incorrectly written in numerical order because you have the positive 6 on the left and negative 2 on the right, and that wouldn't make any sense. So you want to rewrite this to reflect numerical order so that the negative 2 is on the left, positive 6 is on the right, and then you can write your end of notation. So the end of notation for this one, guys, is going to be a bracket with a negative 2, comma, positive 6, close it up with a parentheses. Yes, that's how we know whether or not we're using brackets or parentheses, guys. So be careful because when you're typing it on the computer, if you don't use the correct symbol, the computer will mark it wrong. And guys, here's the last example. And this one has a fraction, so we got to get rid of the fraction. So we're going to start off by multiplying everything by 2. Every single term gets multiplied by 2. So we're going to multiply the negative 13 by 2. We're going to multiply 8 times 2. And we're going to multiply the middle by 2. So make sure you multiply everything by 2 to eliminate the fractions, okay? Well, why isn't this writing? Come on, right? There we go. Now we're going to simplify this out. 2 times negative 13 is negative 26. Less than or equal to, the 2's cancel out. 3p plus 1. 8 times 2 is 16. Now, we've eliminated the fractions. We can go about solving it. And again, your job is to isolate the p in the middle. So you subtract 1 from the middle, 1 from the right, 1 from the left. Eliminate the 1's. Negative 26 and negative 1 adds up to negative 27, less than or equal to 3p. Less than 15, divide everything by 3. And no, you do not change the sign on this one because you didn't divide by a negative. So now, guys, you want to write this in an notation going from left to right. You start off with a bracket with the negative 9. And then comma, positive 5. And then close it off with a parentheses. Remember, the inequality symbol determines if you have a bracket or parentheses. And guys, that's it. Hopefully you've learned something. We're going to go over some of these questions in class as well. So pretty much that's it. Until next time, bye.